Alright, so in this example, we have two forces, force 1 and force 2, that are written in Cartesian form already, and we're asked to determine the magnitude and coordinate direction angles of the resultant force. So the first thing we need to do is we need to define what is our resultant force. Our resultant force is going to be equal to the sum of all of our forces. So in this case, it's going to be force 1 plus force 2. Alright, very easy. Alright, so we can write our resultant force as being the sum of all our x components of force 1 and force 2 plus the sum of all our y components plus the sum of all of our z components times the unit vector k. Alright, so if we do that, we have our resultant vector would be equal to force 1's x component, which is equal to 0 pounds, plus force 2's x component, which is equal to 50 pounds, times the unit vector I, plus the y component of vector x, which is equal to 60 pounds, plus the y component of vector j, which is equal to minus 100 pounds. Alright, and then we have to the last step is to add the final force component of force 2, the z components of both of our forces. So force 1 z component is equal to 80 pounds, and then our y component of our force is equal to 100 pounds. And they're both positive. Alright, so if we do all the algebra, we end up getting 50 pounds. Our resultant force is equal to 50 pounds in the x direction minus 40 pounds in the y direction and 180 pounds in the z direction. Right. So we can find the magnitude of vector r by taking the square root of the sum of our each component squared. So if we square 50 pounds, and we square minus 40 pounds, and we square 180 pounds, and we take the sum of all those squares, and we take the square root of that sum, what we end up getting is 191.05 pounds, which is approximately 191 pounds, right? And that's our magnitude of that force. All right. Then the second part of the problem is we were asked to determine what is the coordinate direction angles of our vector r. So in order to find our coordinate direction angles alpha, beta, and gamma, what we're first going to do is we're going to define our unit vector of r. So that's u of r, which is defined as vector r divided by its magnitude. Alright, so what this will end up being is it will be equal to the x component of vector r divided by the total magnitude of vector r. And then the same thing for the y component would be equal to minus 40 pounds divided by 191.05 pounds. J plus, we would do the same thing for the z component, so we have 180 pounds divided by 191.05 pounds times k. Alright, so if we solve all those fractions, what we end up getting is 0.261712 for the x component, and then for the y component we get minus 0.209369. And then for the z component, we would get 0.947119. Alright, so we can use, so what we know is that the x component, the y component, and the z component can be related to our coordinate direction angles alpha, beta, and gamma through the cosine function. So we know that this term is equal, the x component of our unit vector is equal to cosine of alpha. The y component of our unit vector is equal to cosine beta, and the z component of our unit vector is equal to cosine gamma. So if we take the inverse cosine of our x component of our unit vector, for alpha, what we end up getting is 74.828 degrees, which is approximately 74.8 degrees. If we take the inverse cosine of our y component of our unit vector, what we end up getting is 102.08 degrees, which is approximately 102 degrees. And then if we do the inverse cosine of our z component of our unit vector, what we end up getting is 118.716 degrees, which is approximately 18.7 degrees. All right. So just to wrap up this problem, or to summarize what we did, is we first added together we summed all of our forces in x, all the components of our forces in x, y, and z to determine the total resultant vector in Cartesian form. Once we had our resultant vector in Cartesian form, we could determine its magnitude using the square root of the sum of the squares formula. And then once we had that magnitude, we could then divide each component of our vector by the total overall magnitude of our resultant force. And once we did that, we had our unit vector. And using the components of the unit vector, we could calculate alpha, beta, and gamma using the inverse cosine function.